Hello everyone, my name is Daniel Trejo Camacho, and this video is being recorded to show the progress of my natural language processing project. So I will share the screen, and this is my project, Narrative Memory AI ReZero project. Currently, it is still a prototype, but we will cover in this video the generals of the project, such as the architecture and a quick demo of how the build rack system work, works. So let's start with the architecture. First of all, it's important to remember that currently the large language models hallucinate a little bit when it comes about specific knowledge. For example, the a novel content that is the case of this project, or in a real world, the documents for a specific company. So the architecture used for this project was divided into three phases. The first one is the ETL process that extracts the information in the raw text from the ReZero novel, clean the text, then we generate chunks, and then we generate embeddings to store that vectors into a Chroma database. The second phase of this project is the RAG process. We build a RAG system, we ask a question to that system, and then, based on the prompt in our model, with the retrieved, in this case, chunks of the Chroma database, we generate an answer to that question. And the third phase is the test phase. In this case, we, well, save the answer generated by the model, and we define a test set, and we perform three metrics. The first one is the precision K test. The second one is the top K accuracy test. And the last one is the row test. So let's see a little bit of the code behind this project. Well, here we have the ETL process that I will not run because it is a computational expensive. But the important thing is that when we run this code, we download the text from the web page of the novel, and we store the embeddings into this folder that contains the vector database. After that, we have here our RAG system. We have built the RAG system. I have already run the code to initialize the system, and then we can ask questions to the system. Let's make a test. For example, who stole non-satellas insignia? We ask the question, and just to know what is the rack system in this case doing and where it is extracting the information, I have print all the retrieved chunks. So we have here the information that the model, in this case, Gamma is building, uh, Gamma is using, and well, unfortunately, I had a CUDA error. This happens because I don't have enough RAM memory. So let's make a pause, and I will show you the, in this case, the output to the answer. I'm sorry for the CUDA error. This error arises when I run out of RAM memory, specifically for VRAM memory. And well, I was recording the video and trying to do the demo for this rack system, so I ran out of the VRAM memory. But now we have the answer of the rack system. In this case, we ask the question, who stole non-Satella's insignia? The answer is filled, and our model, our rack system, correctly answered the question. So this is good for the rack system. It is retrieving the correct information. But to see this more in detail, we have the third phase, that is the test phase. As I have mentioned in the beginning of this video, we have three main metrics to perform in this case, the retrieval quality. We have precision K, top accuracy K, top K accuracy, sorry, and then we have the rogue metric. So I will not rerun the whole code, but we will analyze, in this case, the results. For the top K accuracy, we define this test set and well, we add two questions. The first one, for example, kill Rome, and we had to evaluate if it is retrieving the correct chunks. The expected source with where the chunks used for answer the questions could be extracted. In this case, for example, we have the arc 1, chapter 11. So, well, our top K accuracy currently is of 50% because in the first question, the RAG system is not in, well, also the database is not retrieving the correct chunks or, well, the expected chunks to answer the question. While in the second question, it is retrieving the chunks from the expected source. Well, how we can improve these results? What we can do in this case is, for example, adjust the amount of words that each chunk contains in our first phase, the ETL process. So these are improvements that we can add in the future to this project. And the precision gate is a little bit more um, qualitative because we need to evaluate if the chunks retrieved by the database and used by the by the rack system are actually providing information to answer the question. In this case, the overall precision K metric value is also of 50% because none of the retrieved chunks for the first questions actually contains relevant information to answer the question. While for the second question, all the retrieved chunks contains relevant information to answer the question. So as I have mentioned, this is something that we can improve to increase the level of our precision K metric. And our last metric is the rogue, in this case, metric. And we update our test set with the human expected answer because rogue evaluates if our RAG system is answering in a human behavior like. So, well, we add some human, in this case, answers to compare with the answers provided by our RAG system. In this case, we have, well, a decent metric for this prototype because our first metric, the Rogue one, is currently about a 40%. What does this mean? This means that the words used in the answer provided by our rack system are human like, based, of course, on the uh, human expected answer. But our rack system is struggling, in this case, with the row two, that is the sentence itself, because this metric evaluates, well, this is specific, the second one, row two, evaluates if the sentence, in this case, that the rack system output is similar to the sentence, to the whole sentence of the human answer um, test, in this case, answer provided. So, well, our current metric is about a 10%. So this is something that we can improve again, because maybe we can improve the prompt used in our rack system, because currently it's a little bit too general and we don't specify you need to answer like this or like that, no, for example. So this is something that we can improve for future versions of the current project. So this is a general introduction to the project, to the progress that we have today to this prototype. So in conclusion, I would like to add that even though this project could seem that was made just for fun, there are real world applications. For example, imagine you have a customer service company, and imagine that you are capable to transcribe your calls with customers, transform that data into embeddings, and then store them into a vector database. And then you build a rack system that could retrieve that information and solve future customers, in this case, in this case, questions. So this is a real world application. You can use that information to solve the future customers' questions. So thank you so much for your time and have a happy new year.